Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help teach you how to solve logarithmic equations. So, we're just going to go through a bunch of examples here, starting with this first one. So it's, one common practice in equations like this, start by trying to get the logarithm by itself. So if we divide both sides by 6, the new line is going to read natural log of 2x equals, 24 divided by 6, 4. Now, for this one, I would suggest undoing the logarithm or writing it in exponential form. Now remember, natural log means base e. It's typically not written, but remember how to rewrite this. E to the 4th equals 2x. And then we'll just divide everything by 2. So e to the 4th over 2. I don't have a calculator on me, so all you're going to get from this video is exact answers, but that thing's done. E, remember, is the natural exponential number, 2.7, yada, 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 yada. All right, next one. All right, example 2 here. This one also, we probably want to use a similar approach. And the logarithm's already isolated, so I'd start this by rewriting it as an exponential. 5 to the 3rd equals this. Now 5 to the 3rd, I believe, is 125. And then we're just subtracting 3. I'll just write the answer over here. So what are we going to get out of this? X is equal to 122. Okay, moving on. So logarithmic equations sometimes look a lot worse than they are typically. So the next one here, not sure why this is there, but so undoing the logarithm again, we can write this 2 to the 6th equals what's here, 6x plus 8, and 2 to the 6th power is 36. Subtracting 8 from both sides. Let's see, I think that's going to be, what, 28? Whoops. 28 equals 6x. And divide both sides by 6. So x is equal to 28 over 6, which can be rewritten a couple times. I was going to say simplified, but I don't know. Not sure I would call it simpler, really, but I guess in lowest terms, 14/3, and that's done. Moving along. Okay, so this next example's got a little more complication to it, and that's okay. So hopefully you've seen my video on properties of logarithms, and one of them I want to remind you folks of is that a couple of them here. One, the log of a product. So the log of a times b can be written log a plus log b. That probably will come up in some of the examples. Second, the log of a quotient. So log a over b can be written log a minus log b. And that's what we're going to apply here. This can be written log of x plus 11 over 2. Now those are all just standard log base 10s. Remember, if it's not written, it's base 10. And we can do this by comparison. We have log of this thing equals log of this thing. Those two things must be equal. So x plus 11 over 2 must equal 4x plus 3. Oh, let's see. Maybe we multiply everything by 2 if we are kind of bashful of fractions. Just going to kind of look that over. Yeah. Subtracting x from both sides. Subtracting 6 from both sides. And dividing both sides by 7. So it's looking like 5/7 solves that if I haven't made any algebra goofs. I'm going to leave that for the viewer to look it over and tell me about any algebra goofs. Next one. All right, this one too can be combined into one logarithm. And let me scroll down a little bit. So that's going to read, whoops, let's see, that's going to read natural log of x minus 8 over x plus 7 is equal to natural log of x minus 24. And now by comparison here, if natural log of this guy is equal to natural log of this guy, this guys are equal. Oh boy, this one's looking like we're going to end up quadratic. So multiplying both sides by x plus 7. So let's see, first, outer, inner, last. Oh, Jesus Christ, what does that come out to be? 8 or 168, I believe. I'm going to kind of think about that for a minute. 28, yeah, I think that's right. So now we have x minus 7 equals, let's see, x squared. Okay, 7x minus 24x. That minus 17x? Minus 168. I think that's right. Subtracting the x and the 7, so 0 equals, let's see, x squared minus 18x. Okay, and then we'd be adding 7, so I guess that's minus 161. Oh, good grief. Charlie Brown. Don't really see that factoring. So we're just going to run to the quadratic formula. So x is going to be the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over twice a. Now, when I said the b squared, technically b is a minus 18. I usually don't bother writing the minus because it's squared anyway. And I am going to just leave this answer like so because I don't feel like doing any arithmetic. I'll just write it. How about 18 squared? Now by the time we do minus and minus, we're going to get a plus 4 times 161 and then all over 2. Now, some things to consider here. You can't take the logarithm of a negative number. So I'm going to leave it like this. One of these is going to come out negative, note, I'm pretty sure, because this thing is going to be bigger than 18. And when you put that here, that definitely is going to get thrown out because then that thing's going to be negative. So we definitely can throw out the negative. The other thing to check is make sure even the positive one, by the time you put those values here, well, here you'll be fine, but here and here, make sure that we get positive values for the logarithms because you can only take the logarithm of a positive number. So anyway, I think that's the last example here. Yep. Again, the purpose of this example is to help give you an idea of how to solve logarithmic equations. I hope that this has done that for you. Have a great day.